Well, it doesn't apply. I'm not saying it's applied to everyone who was playing domestically then, but we saw a drop off in who was available and who was excelling at the time.
Okay.
And so that's why I always.
So let me just say that again. I said we were supposed to have a little test this week, but because we did, and I planned to use last week to do a couple examples so that, you know, you're familiar with what kind of things I would ask. But since I didn't get to do that, I decided to move back the exam to next week and go through those examples this week. So I also said that in doing the exam, we're going to do a little review of, you know, what you need to do the example. And then I'm going to give you the example and give you time to do it. And once you finish that, then we go through it together. I also said I expect everyone to participate, right? And while I'm on that, let me just tell you, for the exam next week, it will be, you will have to work out the problem similar to like what we're doing today and upload them and send them to me. So it won't be a multiple choice where you call that person and say, what for that question? And him say B, and you know, everybody get A. That kind of stuff.
All right, sir.
So we are going to, go ahead.
The upload, would it be to your email or on Moodle?
To my email, preferably to my email. Okay. All right. So the first thing we're gonna look at, or we're gonna review, is the frequency and phase modulation. Frequency modulation is a system in which the amplitude of the modulated carrier is made constant. So the amplitude is constant, whereas the frequency is varied in accordance with variations of the modulating signal. The first practical system was put forward in 1936 as an alternative to AM in an effort to make radio transmissions more resistant to noise. So that's amplitude modulation or frequency modulation. So what's phase modulation? And I mean, I could easily ask you to define amplitude and phase modulation and give me the difference between them. So what's phase modulation? It's a similar system in which the phase of the carrier is varied instead of the frequency. So frequency modulation, you vary the frequency. Phase modulation, you vary the phase. As in frequency modulation, the amplitude of the carrier remains constant. It's very important. The amplitude remains constant. You are more than familiar with the general equation of an unmodulated wave or carrier wave may be written as a sine wave, right? So you have X, which is the instantaneous value here. And I show you the picture in a minute. Instantaneous value of voltage or current. And A is the maximum amplitude. So X equal A sine omega t plus the phase. Omega is the angular frequency, angular velocity, and phi is the phase angle. So here, omega t is the angle in radians. If any one of these three parameters is there in accordance with another signal, normally of a lower frequency, then the second signal is called the modulation, and the first modulated by the second. So here you have a modulating signal. This is your A. And for amplitude modulation, right? While for phase modulation, no, for frequency modulation, you alter the frequency, get higher frequency here, so on. So this now, the wider these are, the lower the frequency, right? So this is your frequency versus time. And alpha yeah, okay. Need to do this properly at all. Okay. Okay, yeah. Alteration of phase phi will yield phase modulation. The frequency of the carrier is made to vary your frequency modulation. Let's bear with me. It is again whatever you want to be, but sinusoidal signal is very easy to. Signal has two important processes. The amount by which the carrier frequency is varied from its unmodulated value is called the deviation. Is made to, okay, is made, so the deviation is made proportional to the of the modulating voltage. Could also be current. The rate at which this frequency variation or oscillation take place is equal to modulating frequency. Okay. You can read this on your own. Take a minute and read this. Just to shut me up. Everybody seeing it clearly?
Yes, sir.
And do you have any question?
So we're just wondering if we have this particular document.
Huh?
We're wondering if you sent us this document.
Send me this document, but I can. But
Yes.
it's the same thing in the documents I sent you.
Yes, sir, but you have too much knowledge.
Too much knowledge.
Repetition is no insult, sir.
I've argument for me. Hold that. Full argument, man. Okay. So FC is the unmodulated or average carrier frequency. K is a proportionality constant. EM cos omega t is the instantaneous modulating voltage. Again, we could have the current instead, which would have IM. And then again, the sinusoidal is just for the signal, the simplest signal to work with. So here, alpha, which is your maximum deviation, as shown by the plot above is given by this. Okay. So let me see now. Wait. I ask people to do something for you. Come just scan this as two different things. That's right. Okay. Okay. So this is the first example now I want you to try. And I'm going to call on people to tell me what they have. So don't worry, sit down and wait for somebody else to do it.
Sir, what is the AF voltage? Your mouse is blocking the value.
Huh?
Your mouse is blocking the value for the AF voltage in the example, sir.
Okay. Good now?
Yes, sir.
Okay.
for the formula to work out, this was in the notes before this,
Say what?
the formula to work out this.
Yeah,
It was in the notes just now.
yeah, man.
That's what
Well, yes. Yes.
I'll scroll up back to receipt.
You know that let me do this. The mathematical. It might not be a plugin. It might be what was said. So nobody can put them on up yet?
You didn't ask it, sir.
Huh?
Nobody asked it. Think I'll give you time, so.
Now you finish?
Think so. Part of it.
All right. How about the other part? Anybody else do at least part yet?
I did part, sir.
Hmm? So the first question I they ask is that if the audio frequency voltage is no. Yeah. I'm reading what in an FM system, when the audio frequency is 500 hertz and the audio frequency voltage is this. So the frequency is this, the voltage is this, and the deviation is this. And now them say now them are going to change the voltage from 2.4 to 7.2. And they want to know what is the system, what is the new deviation. So look how simple this is now.
Right, sir.
This is your deviation, right? The deviation is directly proportional to the maximum voltage. If you look back here, see a deviation. Okay. That's proportional to your voltage. So how much you get? Is that one line now? With that little bit of information, what you get?
14.4, sir.
Hmm? So it's directly proportional to this, right? So you change, you change your voltage.
Yeah.
You change your voltage. And what else you change? Yeah, you just change your voltage.
Mm.
So this is what you get now. 14.4.
Yeah.
No. What's the modulation index? So now why you think too hard and believe, say, Russia, we are dealing with it. Some simple things may I give. But if you go through the thing them I'm saying, you know, all of that and what we talk about, Understand it. Simple things that us want to. So what's the modulation index?
So you divide the deviation by the audio frequency. So audio frequency voltage. So
Never
So the first one, you divided 4.8 by the 500 hertz. So
when the EM equal 10.
so the deviation there 20.
Mm.
Okay.
so did the question ask for that one, sir?
Modulation index.
Yes,
Yeah,
sir.
the next one, find the modulation in each case, the last question. I think you did show that part yesterday, but all right.
The man will show it, man.
Modulation index, sir.
Mm-hmm.
Sir, na hit no kaki down at bottom, sir.
No,
Yeah,
no,
man.
but the below the one.
Find the modulation index in each case. Mm.
Oh, okay. You know that may not tell us, I never asked it.
Hmm?
That may not tell, but I never asked it.
We'll get it.
We tell you 4.8 divided by the 500.
Mm-hmm. You said that, man. Everybody get it?
So it's supposed to vary, the frequency can vary for frequency modulation, right? So,
Yeah, right.
oh, because I never like is there a case where you would have like a frequency being 500 hertz, like for audio frequency, like constant 500. Like,
I would have, how let me say it? Broadcasting on what you saying there? 500 would too low.
but no, not that you would be too. It's just that if somebody is talking, you don't expect it to frequency to be constant at 500 hertz. Yeah. So I was wondering if like you would use like a range of values for audio frequency.
Sure. Man, that's
I Alright, so when you're talking and you're hearing, is the voltage determine like how low or loud the what you're hearing, right, sir?
If you go back maybe to our first or second class, you know that you're gonna filter, right, out the noise. So at some point, say if you're transmitting, if your carrier frequency is at a certain level or a certain value, and your frequency get too low, then that would filter out. It wouldn't get transmitted to the receiver. But you'd have a band, a filter band.
Okay, so
Sure.
Uh-huh.
All right. So for instance, you're listening to a radio station on one frequency, 103.9, right?
Mm-hmm.
You change that same station have 3 different frequencies that they operate on. And you're on 103.9, and then you change it. Their frequencies are 103.9, 103.5, and 103.1. Zip, right?
Mm-hmm.
You change from 103.9 to either the other two. And you hear, you don't touch the volume any at all. When you change it immediately, as you change it, you hear the station louder. What caused that?
Remember that. Let's look back on this further.
so I think it was in data communication, I think. So a teacher was saying like it has something to do with the power is delivered or something like when if it increase the frequency, then you would probably have
I wish I had
a
the
better signal.
I wish I had have up there the, maybe we still have it here, and I'm check and keep it. I know, and them other something they want you love see that. You want to say like final exam and that thing. All right. I think I gotta find that, but remember, you have your wave, right? And then you have the carrier wave. And you sum the two of them, right? And you send it through a filter. The wave is as in this case, this is voltage. It could be voltage or carrier. So you convert whatever the signal is to a series of to voltage or current, right? and you send that through now to your modulator where it get summed, convoluted, right? And then it comes through a filter, right? To take out the noise. So if you are at 103 and you shift to 101, because remember, the spectrum authority are gonna give you a range where your station are gonna transmit on. Because if all of the station them are just choose where they want to transmit or whatever, then a pure noise are gonna depend. Me transmit from Mandeville and 101, and you transmit from Obi and 101. We don't know we are here, right? So the filter is what's gonna take this signal and confine it to one space, right? Your question is why some get louder and some, get lower. Now, depending on where you are on this wave, your instantaneous voltage is gonna be different, right?
Right.
So although your filter can cover this range, right? Depending on where you are, if you are 101 or 107, your instantaneous voltage is gonna be different. So the power is gonna be different. So the conversion is gonna be different.
Okay. Understand, sir.
See if we can get to an next brain buster. Easy brain buster. Okay. So let's try this one. Let's try this easy one.
Sir,
Mhm.
like I'm trying to understand the frequency modulation. Is it a thing like you have a video and you have a certain frame per second? If you try to with frequency modulation, I can keep it at um uh, a decent frequency and get good video quality. Is that a case or a use of frequency modulation?
Um, let's see how to answer that now. Remember, it's not so much whether it's video, audio, or anything. We just have a number, as you know, a number of modulation technique. Some have advantage and some over some, like amplitude, frequency, phase, right? So all of the, whether it's video or audio or something else, you can use any one of the modulation technique. It's just that some are more efficient and some based on what frequency you're operating or what amplitude you're operating. So I don't want to answer it and say, well, video, if you're transmitting video, it's better to use frequency modulation. It's not really so. You can use anyone, right? But as I think you have a table, we show you the range which modulation frequency is best. I don't know if that answers your question.
I think so, sir.
Look back at that table that I share with you. It's in your notes from last time.
Is the one with the different from up to about 300 something
Mhm.
giga or megahertz or something. Very high frequency and ultra high frequency.
Right.
Oh,
And I show you which modulation technique
okay.
is recommended.
Okay, yes.
Nothing for me yet.
Sir, sir, use look at the equation for frequency modulation, sir. AC cos 2 pi f the carrier frequency times time plus modulation index times sine 2 pi modulation frequency and time. So a single load, the modulation index from the equation that is given 5, and I use omega equals 2 pi fc to get the carrier frequency, to get the carrier frequency and the modulation frequency. I get for the carrier frequency 6 times 10 to the 8 divided by 2 pi equals 954.93 kilohertz. And then I do a similar procedure using the 1250 divided by 2 pi to get 198.94 hertz. And
What's this?
well, yes, sir. Yeah, rounded. And yeah, get the modulation frequency from the equation. and yeah. I didn't get the power though.
Beautiful.
Is it be the carrier the carrier amplitude, the voltage 12. Or you convert it to RMS. Yes. You have to divide it by √2. Okay.
Everybody got that. It's so easy that is. Now I believe in an exam, you have to get enough time, that amount of time to do that, you know. So basically, okay. I think I'm just gonna take a few minutes. Okay, what I'll do, I'll just send this to you for the other example. And how they get the frequency spectrum and the basic function table. So those are the simple kind of things that I will ask you next week.
Could you repeat what you just said, sir?
I said, I'm gonna send you the other example that I have. And, you know, you do the same thing. Look at the question. Give yourself some time to work it out. And then you look at the answer. Right.
So what is this table?
That's the function. The next paragraph, you will, when you read it, you will see what it is. You use it to develop the frequency spectrum.
Okay.
Mm-hmm.
Do you like plot it in Excel or something like that? Just is it even?
Let me show you. You get it from this now. So you start with this. You expand. You start with the basic carrier frequency, and you expand it into all these, and then you plot it.
Okay.
Get this. So let me go to the table now. These are your J for the equation. All right. So if you have any problem with the third example, you can give me a call.
Sir, one last question. When should we submit the report, and should it be like a report write up, or should we just answer the questions and make representation of what the document asks?
That's a good question. I would like to see a report, a regular lab report.
Oh, okay. So at the due date to so
Hmm?
I was asking if you had mentioned a due date.
No, I didn't mention that.
Okay.
I'll tell you at a later time.
Okay.
All right, so next week.
All right.
All right.